Okay, class, welcome back. Today's lecture is going to be about part drawings. It's class exercise 9 in the Google Drive. And really what we're going to learn how to do is to create the drawing that you see here. So we've learned how to create a orthographic projection. We learned about dimensioning, but we never really learned how to create a drawing from scratch. And this is a very important skill set for a mechanical engineer. Mechanical engineers, they're responsible for part drawings, assembly drawings, and fluid power systems like pneumatic or hydraulic schematics. So this is one of the fundamental skill sets of any mechanical engineer. So this is important that we understand how to create one of these from scratch. So what we're given is a start file and a template. So this start file is a simple object that we are going to create a drawing out of it, and we are given a template file for our drawing. Okay, so we're gonna take this tutorial one step at a time, okay, and complete this drawing. So first thing I'm gonna do is hit new, and we're not gonna pick a part, we're gonna pick a drawing this time, okay? And we're going to pick a template. So to do that, we're gonna hit browse, and we're gonna hit template, SLDDRT. So this is the same template that's provided. And if you see here, I'm giving you a SLDDRT. If you want, you can just copy and paste it here if you don't see it here. You can call it CSU template, whatever you want, but you can paste it here, and now you can open it. Okay, and then when you click OK, what you get is the template that you see here. So this is the template that we're going to use. So first thing you might want to do is save this. So I'm going to call this drawing. Okay. And let's talk a little bit about what we have here. If you remember, on a part file, you can be in different modes. You can be in sketch mode, or you can be in modeling mode, right? The way you knew you were in different modes was by the icons on the upper right. You had an arrow icon and an X icon. That's how you kind of knew that you were in a different mode. Same thing on a drawing. On a drawing, you can be in drawing mode, or you can be in template mode. You see how I got an icon here? That means I'm in template mode. If I want to go back to the sheet, I'm in sheet mode. So some students, they ask me, they got some drawings here on the drawing, then they go into template mode, and they realize they can't modify their drawing. And then when they're in drawing mode, they can't modify the template. So you gotta understand where you're at, okay? You gotta understand where you're at on the file, on the drawing, to know what you can and can't edit. So let's talk about the template first, okay? We're not gonna learn how to we're not going to exercise how to create a template, but I want to talk about how you would go about that in case you want to know how. For instance, maybe you're starting your own business and you want to have your own template for your own drawings and things like that. So I'm just going to briefly go over that, but we're not going to exercise that, okay? Because it's a bit of a specialty. All right, let's double click the middle the sheet format, so we're in template mode, and now we can edit what we see. So what we got here is a grid, and the grid is used for referencing. So let's say someone's calling me and he says, hey, there's something wrong with C6, okay? So I know that there's something wrong over here. Or somebody says, hey, you have a missing dimension on B2. So I know there's something wrong here. So this is what these numbers are used. They're used for referencing when you're trying to communicate with machinists and things like that. So on a template, you have that tolerance block, okay, that tells you, hey, if you show me 2 decimal places, this is the precision you communicate. If it's 3, this is what you communicate. So again, this is really good for saving space because you don't want to communicate tolerances on every dimension. So this is a very good generic block. Then you have a logo, okay, of whichever you want. It's just a JPEG. You can copy an image from Microsoft Paint and paste it right here, and then there's your logo. Then here's some standard items here, like the scale. There's material, print number, description, so a lot of different terms. On a professional drawing also, you usually have a second name, so you have like a second pair of eyes review your drawing. So it's always good to have 2 engineers sign off on a drawing because, you know, again, a lot of these parts are really expensive. It takes a long time to machine. You don't want to make a mistake. So usually you have a reference, and then you have the primary engineer. So you have the date that the drawing was made, and then the revision. So remember, we talked about revision. Whenever there's a change made and the drawing was sent out, this revision needs to be increased. Now, in a lot of the older CAD programs, this has to be done by hand, but nowadays with a lot of PDM technology and Git control, a lot of this is done automatically because it's just silly to kind of have to remember all these changes in just one shot. But just be aware, some of these engineering companies do not have that technology. They're not quite at that scale to automate that, and you have to remember to update this revision anytime you make a change, especially after you sent the drawing out. Print number nomenclature, I've seen that vary between projects. Usually there's like a project number, then assembly number dash print number. That kind of varies, but just make sure it's consistent and it's self-intuitive. Okay, it's consistent, it's intuitive, and it makes sense. So those are some of the more important items of a template. But let's talk about how to build one. Let's say you want to create your own template. Okay, so really the best way to do that is just to kind of build a table with lines. You put a bunch of lines just like a sketch. You create a table like this and you build this template any way you want. Okay? And you can even anchor these. You can fix these or make them horizontal so they're black. Okay? You can add you can add labels, things like that, and really build this any way you want. So another thing that you may want to know about is how to extract properties from a model. So for example, if I hit File Properties, all right, and I type in 1, 2, 3, okay, and I click OK. See what happened? It said 1, 2, 3. So that's very clean. That's a clean way to work. You don't want to have to type in text boxes here and start typing material and getting things all misaligned and things like that. You want it to be clean like that. And the way you can do that is by adding a property. All right, if you put a label here and you click link to property, you can link it to a model property. All right, like author, like comments, or current document. Okay, so it can either be a property within the drawing document or it can be within the model property. So you remember what I mean by property is when we created a model, we did file property and we started typing in material, print number, and things like that. So you can bind it to that value, and then next time you insert that model, this property is going to extract. Okay, so again, you can change that to anything you like. Let's say author. Okay, let's say author. So now when you import a model, it's going to update this value to the author, and this is exactly what was done here on this property. Okay, it was linked to the property of that was defined for that. So those are really the main items of a template. Okay, it's about drawing lines, drawing labels, inserting a logo, and then adding properties, just like you see here. Properties that can be either linked to the model or the drawing. So now that we understand the template, let's start building our drawing. And if you ever want to modify the template, okay, you can always right-click, hit Properties, and you can change the size or the template. The size is another kind of important element. Sometimes, let's say you're trying to dimension an engine block. An engine block is pretty complicated. You're not going to be able to fit all the details that you want on a size like this. So you have two alternatives. One is to spec a larger size sheet, okay, much larger. I think there's like 7 different sizes, A, B, C, D, E, F, or something like that. The only thing is with a larger drawing, you need a larger printer, like a plotter, and not every engineering firm has that. An alternate way of doing this is to create a packet of individual drawings. So what you do is on the engine block, you put a bunch of references, a bunch of bunch of notes to say, hey, reference drawing A, B, C. And all these drawings, they become a bundle. They become a bunch of references that can fit inside 8.5 by 11 booklet. And that's another clean way to communicate a complex object like an engine block. So on one sheet you would have just dimensions on the threads. On another sheet you'd have dimensions on the end connection on this engine block. Okay, and then the final assembly will, or the final model will just show a bunch of references. So you got to figure out how to organize it, you know, given the resources that you have. So let's say we're going to start with this size, and we're going to start importing our model through the model view button. So like I said, we were given a model, and it was this. Okay, so here it is. You just click, and you can project it. Project. Okay. And project. So it's kind of nice, isn't it? Because if you remember, it was kind of tedious drawing each of these lines when we were creating orthographic views. So it's kind of nice that this is done automatically in one shot. You can even click this button. It's called standard 3 views, and it kind of just generates all 3 views in one shot. But essentially these 2 buttons are really doing the same thing. Sometimes you want to change the orientation of this. You want this to be like the top view instead of the front view. The way to do that is you gotta select the root view. I'm not talking about the child view. Okay, I'm talking about the root view, the first view you inserted into your drawing. And then you gotta click these boxes. And as you can see, it's changing the orientation. So that's how you change the orientation. Let's say you want to change the orientation on the isometric. To create an isometric, just hit the projected view and go to the side. Let's say you want to change the orientation of that. One way you do that is you can project it somewhere else. So you can project this to the side and then project that, okay, like this. And then you can delete whichever view you don't like and keep the one you like. Okay, so I just showed you how you can really change the projections any way you like. Okay, and then you can change the scale. Alright, there's sheet scale and there's custom scale, so you can have individual scales within a master sheet scale. It's kind of best to just stick to one scale throughout the drawing. This way this stays consistent. Projected and true is for, yeah, I'll show you an example. Really, the only time I've really come across that is, say I want to kind of, you know, put a dimension that kind of aligns with this isometric. You see that? See this dimension? I can only do that if the projection is true. If it's projected, I can't achieve that. So that was the only time I've ever really needed to switch between that or the other. But really, you're never really supposed to dimension an isometric. The only time I had to do that is because when I was creating some tutorials, you know, on the tutorial, sometimes I show renderings of an isometric with dimensions so you can model it. So it was really for educational purposes that I ever had to use this. But in the industry, usually you don't dimension an isometric. Okay, so I'm moving on with the steps. I've just projected it. And now we're going to start cleaning this up a bit. First thing we're going to do is delete these excessive center lines. I just don't like them. Okay, I just don't like anything that it generates. Next thing we're going to do is turn off these tangent edges. Usually you don't leave that on an orthographic. It's just confusing. It just makes you think whether this is like a chamfer or like a recess or anything like that. Usually you turn that off. So what you do is you go to View, Display, Tangent Edges Removed. And we're going to do that on all 3 views. You have to select the view. Alright, you got to select the view for this to work. Alright, you can't just have it do it on all. I'm going to do it on this view as well. Okay, looks good. So I'm just going to spread this out a bit. Let's see what else. I think on the side view it's not really a projection. It's actually a section view. So I'll tell you what, I'm going to select it and hit delete, and then I'm going to hit section view. And before I do the section view though, let me turn on my hidden lines. Alright, so I'm going to turn on my hidden lines. All I do is I select the view and I change the view to hidden lines visible. I'm going to do the same thing to the top view. Okay, so now that I see where this hole is, I'm going to hit section view and I'm going to snap to the center here. I'm going to click OK, and then I'm going to drag over. So how cool is that? In just one shot, we spent a whole lecture learning how to draw these by hand. In just one shot, you create this whole view. So as you can see here, it says section AA. You got your cutting plane line with the 2 dashes. It's all done in one shot. And if you want to change the direction, you can do that too. Let me see here. Direction. Flip direction. You see, you can change all that. You can even change the direction of these, you know, these section lines. You can do all that. Anything you want, you can do. You can do an offset section view too. All right. You just click this, and then you keep offsetting it. See, hey, I want this offset there. I want this offset there. So again, I've used this one all the time. So don't feel like this is a trivial line type. That's a very good line to use. So we got our views. They look pretty good. Let me save this. I'm gonna save this. Yeah, and we got our hidden lines. We got our visible lines. And now what we're gonna do is add some center lines. So there's 3 ways you can add a center line. One is this one, center line. Here's 1, here's 2, here's 3. Okay, and I'll explain where you want to use all 3 of them. Okay, the first one is the center mark. As you know, this is when you want to define a circular feature on its perpendicular, just like you see here. The problem is sometimes these are kind of small, so I kind of like to bypass the value and I actually make this a little bigger, just because typically this is supposed to be 1/8. Alright, and I like to kind of just make it easy to read. Again, all of this is about clarity. Okay, it's all about clarity. You want a clean model. Okay, so that's the first type of center line. The next one is the center line that looks like this. And here's how this works. You select 2 symmetrical lines and it builds a center line in between. But you got to select 2 symmetrical features for this to work. Alright, so this is what's good. I'm going to put one here too. Sometimes it adds duplicate lines and I don't like that. You know, again, try to extend 1/8. That looks good. This one is not really symmetrical about the whole model. So let me show you another way you can create a center line. Okay, it's just this one. This one is like custom. You can make it go anywhere you want. So remember, center lines are supposed to connect together. So this is why I connected the 2 just like that. Also, you'll notice that this is concentric. This fill is concentric about the center. So what I'm going to do is extend this out because this is still sharing the same center as that. Same with this. See that fillet is sharing the same center. Okay. And then before we forget, let me update the template below, file properties. Okay. So it's usually best to keep capital letters in mechanical drawings. Again, it's all about clarity. Remember, we're using sans serif fonts. There's no serifs in this font. It's just supposed to be very easy to read. Again, it's all about clarity. All of this is, it's a very technical drawing, and the whole purpose of this is so that you get this model. You get this object back exactly the way you wanted it to be without any errors. All right, I'll tell you what, I think we're ready to add the dimensions. Okay, so let me show you different ways you can add dimensions. The first way is through the whole callout tool. Watch what happens when I hit the whole callout tool. You hit the outermost circle, and look at that. You get all that nomenclature, just like we talked about. Because we use the whole wizard tool, we get all that nomenclature in one shot. All right, let's see. So that was using that. Now let's try using the Smart Dimension tool. Again, we're going to pick a reference point and we're going to dimension, just like what you see here. just like that. We pick a reference point, which is here, and we start dimensioning. Okay. Everything has to be grouped about that point because it's easier to program like this. It also reduces your stack up error. This fillet is going to have a 2x. You ready? 2x, just like that. This one's also 2 inches, but the reason I'm going to put it separately is because it's inward. This one's external, this one's internal. Again, I just feel like it would be a little confusing if I put 3, even though they're slightly different. This is this circle here. It's just a regular clearance hole. When it's a really simple hole like that, I just use the dimension tool. I don't really use the hole wizard for that. When it's just a small clearance hole like that. I'm just going to 2x, and I'm going to say through. You can use through or through all. Never had problem using either or. So this looks pretty good. You notice how I didn't put a dimension here or here? It's because this is a very unique model. Because this is concentric about this, all I need to know to build this feature is the center of that, this fillet, and the depth of it, which I'll define later down. And I know exactly how big this is. So this is a residual edge. I don't need to dimension that. If I know this feature, I know I can fully define this whole object. So you got to think about that. You got to think about how it's going to get machined, and then you'll know what you need to dimension and what you don't need to dimension. Okay, I think that's pretty good for the top view. Let's try the front view here. Okay, now remember, when you dimension, you gotta find the characteristic view. These holes are characterized in this view. They're not characterized here. That's why I'm dimensioning them here. But here, this chamfer here is characterized on this view. That's why I'm dimensioning it here. You see, so it's those like 20 rules that we talked about, right? Again, I'm trying to keep the dimensions between the views as much as I can. Again, sometimes you're gonna break the rule, but try not to if you don't have to. Okay, I need to define this depth here. You see this? I need to define this depth. The reason I'm going from the bottom is because I'm grouping from the bottom on this view. The reason I gotta define it is because I'm not defining it anywhere else. This depth here, this 1, is just defining this counterbore. This counterbore that's all over here. Again, that's why we use leaders with internal notes to define a hole, because we don't want to put dimensions on this view to define a hole. We want to use a leader because that's well understood. So this defines this feature, but it does not define this pocket, which is completely different. So that's why we need to define it there. Sometimes I could agree that this 1 could be considered a little confusing by some. Okay, they may not be fully aware if this is picking up from here to here. So if that may be confusing, what I sometimes do is reference this. See this? We talked about referencing. It means that this is a duplicate dimension, but it's just there to reduce confusion. All right. Meaning when you send this drawing out, it's not going to get measured. This is not going to get measured. This is going to get measured. This is going to get measured. But before they ship it out, they're not going to measure this. This is just for clarity. Okay. If I wanted to change the precision, I could do that by just changing those numbers. I could even change this to a bilateral and change whatever that's supposed to be. Okay. But for this tutorial, we don't need to go to that level of detail. This is just going to follow the block tolerance that we see here. Okay, so let's see. So let's see if I'm missing any dimensions. Okay, I'm trying to build this object. I have the width, length, and height, and then I have this chamfer here. So it's going to cut this and there. Just cut the chamfer, and then let's see what else. We have 2 through holes here. I need to know the x and y position of those. And I know they're through, I know their diameter, so we're good. We got these. Then we need to know the size of the pocket. We know the center of the pocket and the fillet and how deep it is. Okay. We also know the fillet on the outside to cut the round. We also know where to cut this and how low. Alright. And then finally we need to know the details of the counterbore. So it looks like I don't have any missing dimensions. The only duplicate dimension I have is this. I never needed to tap onto it. But again, because it is referenced, then we're in good shape. Okay, so again, it's best to visualize how this is going to get machined. I think that's really the best way to find any missing dimensions or duplicate dimensions and anything like that. So I'm just going to scatter this a little bit so make it more clear, more clean. Okay, I want to utilize the space as much as I can. I'm going to hit save, Control S to save. Okay, I'm now going to add some notes. So sometimes it's hard to communicate everything you want to communicate with just the dimensions. So a lot of times it's good to add some notes. So one of the most common notes on a drawing. First of all, I like to use numbers instead of bulletins because you can reference the number. You can call someone and say, hey, check out note number 2. Instead of just a bulletin point. Well, one of the most common notes is break sharp corners. I mean, most machinists know to break sharp corners. It's kind of a weird phrase, but all it means is just to remove burrs from the outside. So remove burrs from the holes, from the edges. Sometimes it's good to say, to give an allowance for radii on cylindrical corners. It doesn't apply to this model, but sometimes when you have a cylindrical object, it's good to give an allowance on the corners to say, hey, I don't really need it to be a sharp corner. So because of the lathe insert radius, so you can say, hey, it's okay if it's 8 thousandths or larger on that corner. Sometimes I like to mark the part number on part, and I usually put a note. I put a note where I want it marked, and I even model the location, the mark that I want, print number ABC or whatever. Sometimes I said this as optional though, because a lot of times I'm in a rush and maybe the shop doesn't have a laser marker or whatever, so that one's not too critical. There are other notes that I've used over the years. For example, on packaging, sometimes I've had a situation where there was glue left on the part because of the duct tape they use. So I was there sitting there with glue gone and removing this glue, and it was kind of tedious. So sometimes I put a note to say, hey, don't use packaging materials which may leave glue residue on the part. Sometimes I need special coats. I need like a black oxide or a clear coat anodize or hard coat anodize on my parts. So sometimes I have a little note on the material to say this is what I want. Okay, I want these special coats for corrosion resistance, for wear resistance. Sometimes also I want to communicate symmetry. Let's say this was symmetrical on this axis. I mean, I can communicate symmetry with a note, right? With a CL symbol. This is a really good way to communicate symmetry, like this. But another way you can do that is with a datum. Okay, whoops, datum. Okay, you say, hey, this line is A, and then you can say all features symmetrical about A. Datum A, okay? Something like that. So that could be another note that I've used. Sometimes you see drawings that say units are inches, but it's already on my block tolerance here. Dimensions are in inches, so that's already kind of communicated. Okay, so I'm just going to undo this. Also, notice the description material and print. Those are not properties from the drawing. Those are, see, it says even see model properties. Those are properties from the model. So remember, when you open the model and you hit file properties and you hit material print number, okay, just like this, file properties, you got to go on the model, not the drawing. Okay, material, because this is where it's bound. I bound those items to the model. The reason I did that is because there could be multiple drawings pertinent to that model. So when you hit material, you don't want that to be bound to the drawing. You want it to be bound to the model because it's just a better way to work. Let's say you got to update the material. You don't want to update 1,000 drawings because you'll forget, you'll make a mistake. But if you update the material on just the model, all the drawings are going to update. So the reason these three properties are relevant to the model is because when you work in the industry, you want the properties that are relevant to the model to be connected to it. Okay, so these are relative to the drawing. These three properties are relevant to the model. All right, so this is really the basics of creating a drawing, but there are other things that you can do to this. There's the geometric tolerancing that we talked about. Okay, and you can go crazy with these. Okay, you can add these any way you want. Let's say you want like a flatness or circular tolerance on this reference with the maximum material condition. You can change all those items here, as you can see. Yeah, there it is. So yeah, that's all the GD&T material, geometric tolerancing and dimensioning. You can change all of that here. So another thing you can do are surface finish symbols. So maybe you want to say, hey, what's the RA of this? 0.6, or what's the RA is kind of like the peak and valley average of a surface. But that's another thing you don't really define with the dimensions. I mean, you're saying, hey, these are the surfaces, but you don't say anything about the surface. Is it a mirror-like finish? Is it like really granular, like a cast finish? So you can set these numbers. You can even say, what is the granular direction? Is it parallel? Is it crossed? Is it radial? You can set all these things. The only times in my experience that I've had to spec surface finish symbols is one was in bearing design. With bearings, a lot of times when you want to maintain a certain lubrication thickness between the housing and the rollers, sometimes you have to polish the surfaces, otherwise the rollers will contact and create heat and wear out your bearings. So to maintain that minimum film thickness, sometimes you have to specify special lapping surface finishes to achieve that. Another time I was working with sheet metal, and the machinist was asking about the direction of the grain based on what he had available, and I had to communicate that. And then a third time was with the semiconductor industry for manufacturing transistors, and in that industry it's relatively cleanliness and purity is very important, so I had to work a lot with surface finishes to maintain the purity of the stainless steel, so that contamination doesn't affect manufacturing those wafers. So you may come across these specifications, and again, there are thousands and thousands of other symbols. It's not just what you see here. There's PNID symbols, electrical symbols, hydraulic symbols, and there's like thousands and thousands of other tools and symbols that you can put on your drawing. But I'm just talking about some of the basics. You also have the weld symbols, okay? Maybe you want to say, hey, weld all around, and then weld at the site. Maybe you're welding some sort of I-beam structure or something like that, and then you can even specify like what kind of groove you want to cut. I think it's somewhere here. It says what kind of groove you want, and then whether you want to grind it after. I'm not a welding engineer, but you can really specify a lot with this symbol. And what I've found is a lot of times for most of the welding I've needed, I never really need to go that crazy. Usually just a simple symbol like that is okay. So usually I just talk to the expert shop the expert at the manufacturing shop or the fab shop, and I say this is what I want. He's like, okay, yeah, I let me figure it out. So I try not to go crazy. I do weld quite a bit on my designs. Like for example, on this design, sometimes you may consider building this as two pieces. You have a plate here with two holes that gets welded on this block. Okay, sometimes engineers do that because you don't want to machine all this material out. It's a lot of work, a lot of chips. All right, so that's the weld symbols, and then there's other things you may want to know about, like the make block. This is a little bit more relevant for like AutoCAD. But let's say you have like a symbol for like some kind of pump. Maybe you want to design your own symbol. Right now these lines are on their own, but in AutoCAD really was famous for making block. That was its main. It wasn't just creating lines, it was just that you can group your lines. As you can see here, here's a block, and now I can copy this block, okay? If I want to return to its entities, you explode block, and now I have access to each of those lines. So you can do that in SolidWorks. But really, SolidWorks is not used to be used as AutoCAD. SolidWorks is used to be used as a modeling tool. What I mean by that is I can open this model, I can change this number, okay? I can do that, and everything updates. You see? Let me move this back a bit. I mean, it depends how you model it, how you bound the pieces, but okay, something like that, for example. And then you go back to your drawing. Okay, and then the lines update. I mean, you're gonna get errors that you're gonna fix, but the idea is that all the lines update, all the dimensions update. So that's what SolidWorks is known for, is that ability to interconnect these pieces. So there's also the detail view. Sometimes I got a really tiny detail here, and I don't want to create a new drawing for it. So I create a detail view like this. And I usually do a full outline. And I make it even a little bigger. So it kind of zooms in. You see what I'm saying? It makes it bigger. Okay. And this way I can even dimension what I see on the detail view. I can dimension this and whatever. And this way I save myself. See, I put detail C and I can save myself a little bit of space. So I kind of like using that view. There's also an auxiliary view. I've actually never used that view, but it's when you have a view on an incline, you want to show a perpendicular. It gives you this, and there's your auxiliary. So this surface is on the perpendicular. So that's what an auxiliary view is. There's breakout views. So again, or break view. This is good again if you have like a really long object. You can break it in like that. And when you add a dimension, you get this zigzag. See that? It says, hey, there's a broken section of this object. This only makes sense for long pieces that have nothing going on. You sandwich it, you compress it to save some space. Alright, so that's a nice tool to use. Ordinate dimensioning, that's another way you can dimension. Alright, it's very easy. You pick a 0, and then everything picks off from there. Very easy to use. No arrowheads, no nothing. It's very simple, and a lot of people like using that. And then finally, there's the chamfer dimension tool, which is shown here. Chamfer dimension, and it's just a way to save dimensioning on some of these. You just have to pick a line. Just pick a line, and it's kind of cool. In just one dimension, you communicate this whole chamfer. See, it says the size is 4 by 45 degrees. So that's a nice way to save some space for dimensioning a chamfer. There's a whole lot more to drawings, but this should really get you going on the basics. Finally, when you're done, you can just save this as a PDF. All right, and look how clean this is. Okay, look how clean this is. See that? This is good. Like a PDF is really good because not it's good for sending to coworkers and suppliers because not everyone has SolidWorks, and SolidWorks is very dependent on other files. It's dependent on files you have in your directory, so not everyone's going to be able to open your SLD DRW file. But a PDF, you can open it anywhere, and it's just good practice. It's good practice to to use this format. Also, a lot of times when we work for a big company, there's a lot of shared folders, and some people can tend to change the name of certain file paths, and that could destroy like all your part models. And what happens is every time you try to open a drawing, it always comes up empty because someone destroyed the path of the directory. So with a PDF, you don't come across that issue because there's no dependency. So it's always good. I encourage you to always save a PDF after you're done with your drawing. Okay, so that concludes the tutorial on creating drawings, and that's the process.